Hi ladies. So we are looking at leaves next. Here we go. So basically, again, we're talking about monocots and dicots. Now remember that monocots have one seed leaf. So when they come out of the ground, they've only got one leaf. With dicots, di means two. So they have two seed leaves when they come out of the ground after they germinate. Now, let's have a look here. There are heaps and heaps of different sorts of leaves. Now, the most common, this is so with dicots, we have the lamina. So that's the leaf itself. Then we have this net-like leaf veins. Okay, it's your stereotypical leaf veins. Okay, now we have the midrib, that is the main one that goes up the middle of the leaf. Now they all run into that. Then we have the petiole, which is basically think of it as the leaf stem, and we have stipules. We don't really need to learn about stipules though, but petioles, they are the stem of the leaf. Okay, so we have a look at this stuff here. We've got the lamina, the midrib, which all the little leaf veins run into. We have the petioles, and that's the main stuff. Okay, now just remember that the xylem and phloem are in the vascular tissue. Okay, so the veins and the midrib is made up of xylem and phloem. Now, this is a diagram of a monocot leaf. Now, we can tell the difference between monocot leaves and dicot. Monocots have these parallel leaf veins. So they don't run into each other, they run parallel up the leaf. Now, they don't have petioles either. We can see this bit here on our diagram. The leaf actually wraps around the stem. Okay, so the stem itself is providing support from the leaf that has grown from this nodal area here. Now we've got water movement. So basically, plants use water. So for non-woody plants, they use water to provide structure. Okay, so that's when we see plants that have gone through drought conditions or gone really dry, they start to wilt. That's because there's no water pressure in the plant holding them up. They're a bit like a balloon that's gone flat. Okay, so we rely on this water pressure for the plants to be rigid. Okay, now let's have a look here. So water enters the plants through the roots. It is drawn up into the stem and into the leaves. The water exits the plants through pores called stomates into the atmosphere immediately surrounding the plant. The loss of water from the surface of a plant is called transpiration. Daily weather changes influence the movement of water through the plant. So the stomate and the stomata. Now, this is all about water movement. Now, what we've got is we've got these little, I'm going to do a really crap diagram for us. We've got these cells. No, that won't do. We've got these jelly bean shaped cells that look a little bit like this. Okay. Now, the inner wall of these jelly bean shaped cells is thicker than the outer wall. Now, what happens is when there's lots of water in the plant, that we create this hole here, okay? So the more water, we have a larger hole, a larger stomate, and the water is free to move through it, okay? So when there's lots of water, the water can flow freely through the plant. Now, that is because of these thicker walls, okay? They don't expand, and so as the cells fill up with water, it creates that pore. Now, when these cells become less full of water, we have the cells flat against each other like that, okay? So they don't let any water out. So it's a really clever adaptation for the plants to maintain their water, okay? So we have carbon dioxide going in and we have water going out. Carbon dioxide in and water out through these pores in the leaves. Now these stomates are usually on the bottom side of the leaves. If they're on the top side, they'd lose too much water. The top side of our leaves have a waxy cuticle, which is sort of like a sunscreen. It's a waxy, you'll see it on plants, it's shinier on the top side, and that's to keep the water in the plants, okay? Now, we need carbon dioxide going into the plant simply for photosynthesis. Rightio, next page. Okay, so stomata open and close in response to humidity, light, and soil moisture levels. All of these things affect plant growth. Now, let's have a look here. So stomata close when water is in short supply. Okay, this occurs even if light intensity is high. In well-watered soil, the processes of transpiration and photosynthesis are affected by daily light intensity. The supply of water to plants depends on soil moisture levels. These are affected by a number of processes: evaporation, transpiration, and precipitation. Now, transpiration is just the movement of water through a plant. Evaporation is when water evaporates, it goes from a solid into a gas. Okay, precipitation is just when water falls as rain, sleet, snow, hail. Now, structure and function. Let's have a look here. So in agriculture, the main thing with leaves is we can harvest the leaves themselves for stuff like vegetables. So edible leaves and stuff like that. We forage with pastures. We can use the leaves for pasture. But the main function for a lot of our grains and stuff like that, leaves are the engines that fill the grain with nutrients, okay, through photosynthesis and respiration processes. Okay, let's have a look. Now, this is a cross-section of a leaf. I'll just zoom out a little bit. Up the top, we have epidermal cells, and then we have, I might label this as we go. So we have epidermal cells, and then we have palisade mesophyll cells. So we have palisade cells. Now, around the outside of these cells, I should be doing this in green, we have chloroplasts. Now, these chloroplasts have a green substance called chlorophyll, and that's what we use. That's where photosynthesis occurs. Okay. Now, these cells are standing upright like that to allow as much light in as possible. Okay. Now, there are still some chloroplasts in these other cells, but not as many. Okay. They're mainly in the palisade cells. So these are the spongy mesophyll cells. Throughout the leaf, we also have vascular bundles. So vascular bundles, again, are for transport. So we have xylem transporting water up out of the roots, and then we have phloem transporting any products of photosynthesis back through to the rest of the plant wherever it's needed. Okay, we can see down the bottom here, these two cells are our stomata. Okay, so they create that gap where water can come out, water vapor can come out, and carbon dioxide can go in. Rightio, I hope that helps.